Hi guys, my name is Anthony and I'm an application engineer here at Iconics USA. Now usually we're known for our webinars which cover our associated research products and the tests those products can perform. But today we wanted to make a shorter video touching on the main points of one specific subject. So today we're going to discuss the Hipot test. Now the Hipot test can be called a few different things: dielectric withstand test, dielectric strength test, over voltage test. It can also be defined differently depending on what standard you're reading. Some might say between live parts and accessible metal parts, which are protectively earthed, while the next standard might state a test between primary wiring and accessible non-current carrying metal parts that can become energized. These are all ways of saying the same thing. It's a test to verify the integrity of the insulation between a circuit which was designed to carry current and a different circuit, usually the ground circuit, which was designed for protection in case there's a fault, but it's there to protect your user. Now, for a better visualization of what I'm referring to, let's go to our board and get a clearer picture of what's happening during a Hipot test. Okay guys, so now that we're here in front of our whiteboard, I can draw some diagrams to better explain what's happening during the Hipot test. So, Class 1 product we know has its line and neutral, which will be represented by this circuit. We have a chassis that's there to protect its users from coming into contact with any current that's intended to flow on the line and neutral. And then we have our ground circuit, which is used to ground the enclosure. Okay, so during a Hipot test, we want to use this to represent the Hipot tester. This is our AC source of where our HV is coming from. We will be sending high voltage to line and neutral shorted, right? So this entire circuit is now at the high side of that high voltage. I shouldn't say high voltage is applied to line neutral. High voltage is applied to the insulation. But how do we do that? By putting the high side of that voltage on our mains and that low side sent to ground. Right? Our entire chassis is grounded, so that electric field or that voltage, that force is going to be around our entire DUT. So now we've created these capacitors representing the insulation of our product all around our product. And what we want to know is, will any of these electrons that are floating on our line and neutral, which have now been given this force, this energy to want to break through this area, will that happen? If that does, if electrons do find its way through, well, they will be returned to our instrument and be measured by how much leakage has occurred. Now, if there's a complete breakdown, that means that these electrons have found a path through almost as a short, and our Hipot tester will report a breakdown. That's why when spools of cables, manufacturers of cables, right, they test these spools of cables, but in essence all they're really doing is, if we can take a crosshatch of what's happening, these cables have various conductors inside of them, and those conductors all have insulation around them. And so how do you test to make sure through this entire spool there's no crinks, there's no cuts, there's no places where the insulation has become weak? Well, again, you'd set one side to HV, the other one as your return, or your low side, your high side, and again, that electric field is now in between these spaces checking for any leakage. Okay, so that was just kind of a quick summary of what's happening during a Hipot test, but I think for a clearer picture, let's set a test up in the lab. I can actually show you that air gap where current is arcing through, and hopefully that'll better explain what occurs in your product when we see a breakdown. Great, so now that we're in the lab, let me just explain what we have in front of us. So first we have our Hipot series Hipot tester. We have an ACW Hipot test programmed in at about 2000 volts, right? And we have that connected to these arcing spheres. Now, before we do a real test and connect a real product, we wanted this to represent what happens during a Hipot test. So if we zoom into this, we can see that there's an air gap in between the spheres. Now that represents the insulation in your product. Now each sphere on each side represents a circuit of your product. Right? The left sphere can be your mains input or your current carrying conductors, while your right sphere represents your ground circuit or your grounded metal accessible parts. Okay, now we have high voltage on one side of the spheres and our low side of the voltage or the return on the other. So now let's see what happens when we start a test. And what I'm going to do is keep increasing the voltage. Now what's happening here is we have a force pressing against this insulation. Electrons are looking for a way to break through. And as we increase the voltage, that force increases. So we're a little bit past 2100 volts, 2200. And if I slow down, we get a failure, a breakdown. That means greater than 20 milliamps of current just broke through that air gap insulation. And if we set it in slow-mo, we can kind of see what's happening. So with that slow-mo, you just saw the arc happen, which meant the energy provided to the spheres was enough to let those electrons break through the insulation. Okay, so we wanted to show you that so you can get a good visualization of what's happening to your product when you get a breakdown on your Hipot test. So next, let's set up a real UUT, a real world product, to look at what type of leakage we're seeing. So now let's take your normal industry heating element, right, which has your line neutral shorted. Now we'll zoom in, but you can see this orange insulation that's meant to protect any current flowing through line and neutral from leaking onto the grounded exterior. So what we'll do now is perform a Hipot test on this product by connecting high voltage to the line and neutral. I'm going to return on the grounded chassis. Let's hit test here. And after 1 second, you can see a sustained leakage of about 627 microamps. So what's that tell us? That tells us that there's a capacitive nature to this heating element, right? And so there is some reactive current occurring when you apply AC voltage at about 627 microamps, but we do not get a breakdown. So this insulation has quality and you've passed your Hipot test. Great, so now that we've passed our Hipot test with our more industrial heating element, which involved using the alligator clips, let's move on to something a little bit more common that actually has your class 1 3-prong line cord. So this LED lamp comes with a bunch of screws which ideally are grounded, which gives us perfect access to ground. And again, we have our 3-prong line cord, which gives us access to the mains, line and neutral, and the ground stud. So we're going to plug into our Associated Research adapter box. This adapter box gets directly plugged into the outputs of the Hipot series. And as I plug in, now the product can receive the appropriate high voltage to its mains, and we have our return clip here that I should be able to plug into any metal part of the product, and it should be grounded. Now, as we zoom in here, you may have noticed this green light turned on. So what that means is the product has a built-in continuity test, meaning I've now access to your ground through the adapter box, and I've just returned the alligator clip. We're checking for continuity. We see the green light. We know that the ground circuit has less than 1 ohm. Again, that's just an extra feature, ground continuity. We can touch on that a little bit more in future videos. So now I'm going to hit the test button and we'll see what happens. This is a 1 second test. Again, you may have seen the LED actually turn on a little bit, which is something we see with LED lamps when Hipot testing. But you can see we leaked about 589 microamps, which again, for an AC Hipot test, that's expected. A little bit of reactive current is to be seen in every ACW test. But more importantly, we can kind of zoom into the screen and see what the results are telling us. We have 1.24 kilovolts, which is our test voltage. We have 1 second, which is our dwell time. that's standard for production, and again our leakage value, which gives us a pass. If we were to have gotten a breakdown right internally in this lamp, we would have seen one of those arcs that we saw in the slow motion video. Okay, so that was a quick summary on how to test an industrial product with your alligator clips, and now using something that has your 3-prong line cord and the adapter box. Great guys, so now that we've finished in the lab, we've fully covered the definition of a Hipot test. We took you to the whiteboard and drew some diagrams explaining the physics behind the Hipot test. And we just finished covering what a pass, fail, and more importantly, a breakdown looks like when you're performing this test on your product. So if you feel you need a little bit more information, feel free to contact me at the information shown on the screen. And remember, there's always application consulting, which we can provide on-site training, create custom testing guides. So we hope you found this information valuable and we answered all your questions. We appreciate your attention and we look forward to seeing you on our next video. Thanks.